Hello students! Today we are going to be covering a lesson on combining like terms. This is lesson 3 of our unit. Before we talk about like terms, we need to know what the word terms means. So our definition of terms is simply parts of an algebraic expression separated by plus or minus signs. So that's going to determine what the terms are of our algebraic expressions. If you look at the little note, it says for our purposes we will include the sign to the left with each term. So that's going to be very important. If we look at the algebraic expression 6x squared plus 4x minus 10, I have each of the terms highlighted in a different color for you. 6x squared, that's going to be a positive because there's no sign to the left. If there's not a sign to the left, the term is positive. There's a plus in front of the 4x, so that's going to be a positive 4x, and then a minus or a subtraction sign in front of the 10, so that's going to be a minus 10. So in this algebraic expression, there are 3 terms. So make sure you have that copied down in your notes. If you need to pause the video, please do so. Some more math vocabulary. The number in front of a variable. The number in front of a variable is called the coefficient. So the number in front of the variable is the coefficient. If we look at 6x squared, the coefficient of 6x squared is 6, and in 4y, the coefficient of 4y is 4. And delete that so you can see those words. This little important box over here, that's going to be very important for you. There is always a coefficient in front of the variable. If you don't see the coefficient, it is understood to be 1. So in an algebraic expression, we have coefficients, which are the numbers in front of a variable. And then we also have a term that does not contain a variable. So if you see a term in an algebraic expression that does not contain a variable, that term is known as a constant. If I can get that to enlarge for you. There we go. That is known as a constant. And at the bottom of this screen we have 3n squared plus 4n minus 8. Again, we want to include the sign that comes in front of the term, so the minus 8 is a constant in the expression above. Let's look at a few examples dealing with these new vocabulary words that we just covered. Examples 1 and 2 talks about the coefficients of the algebraic expressions. So in example 1, the coefficient of negative 8n cubed, that's going to be the number that comes right before the variable, so that's going to be the negative 8. The coefficient will be negative 8. The coefficient of r to the 6th power. Remember that there is always a coefficient in front of the variable. If the coefficient is not shown, it is understood to be 1. So the coefficient of r to the 6th power will just be 1. In examples 3 and 4, we are asked to find the constant in the algebraic expression. 4j minus 5k plus 9 minus 2k squared. The only term that does not have a variable is the plus 9, so 9 is our constant. And in example 4, negative 6a minus 2 plus b to the 4th, the 2 is the only term that does not have a variable. Remember to include the sign that's directly in front of it, so our constant is a negative 2. So now that we have those terms understood, now we are going to look at like and unlike terms. So like and unlike terms, first we're going to look at our definition of like terms. Like terms are simply terms that are exactly the same or are different only in their coefficients. So everything has to be exactly the same except the coefficient could be different. So in blue, you will see a list of examples of like terms. Those are, if you notice, the variables are exactly the same. In red, we have examples of unlike terms. In that case, the variables are different. They might be different variables. The variables may just be different with their exponents. So terms that are not like are obviously called unlike terms. So please make sure you have this copied in your notes. Take a minute and pause the video if you need to do so. We are going to move on to a few more examples. All we are going to be doing in these 4 examples is listing the terms and then stating whether or not they are like or unlike. So in example 5, it has 2 terms. The first term is 8n cubed. The second term is negative 2n cubed. These terms are like terms because their variables are exactly the same. They are both n cubed. In example 6, negative 6a squared b plus 3ab squared. The terms, the first term is negative 6a squared b. The second term is a positive 3ab squared. So those are our 2 terms. These terms are unlike because our a in the first term is squared and it is not squared in the second term. And the b in the first term is just b. In the second term it is b squared. So these are unlike. They are not exactly the same. If you take a minute, please pause the video now, try examples 7 and 8 on your own, and please bring them into your teacher to have them check to make sure that you have done these examples correct. Now we are going to get into the meat of the lesson. This is combining like terms. This is going to be very important for the remainder of Algebra 1. Combining like terms. As part of simplifying an algebraic expression, which we covered in previous lessons, like terms must be combined into one term. This is done by simply adding or subtracting the coefficients of each like term and keeping the variables the same. So that's going to be very important. You're just going to add or subtract the coefficients. The variables stay the same. If terms are unlike, they can never ever be combined. The expression just stays the way it is if you can't combine any like terms. So this box is very important. Please make sure you have it copied in your notes for future reference. We are going to look at 2 examples to practice combining like terms. 3x plus 9x in example 9. Those terms are like. They are exactly the same. So we are going to combine the 3 and the 9 by adding them together. 3 plus 9 is 12. We bring down the variable. That stays the same. It does not change at all. In example 10, 8c plus 4c cubed minus 7c plus 2c cubed. We have an 8c. We want to find a term that is like 8c. That is negative 7c. So 8c and negative 7c, when we combine them, 8 plus negative 7, or 8 minus 7, is just 1. So we can write that simply as just c. The other terms in the algebraic expression, positive 4c cubed and positive 2c cubed, those are like terms, so when we combine them, 4 plus 2 gives us 6c cubed. Our variable stays the same. The next thing we are going to look at is going back to the distributive property, which we talked about back in a previous lesson. Remember that the distributive property is used to get rid of grouping symbols when we cannot combine like terms inside the parentheses. So in example 11, 5 times the quantity of 4x minus 5. Those terms inside the parentheses are unlike. We cannot combine them together. So we're going to use the distributive property, and we are going to distribute the 5 to the 4x and the 5 to the negative 5. 5 times 4x gives us 20x. 5 times negative 5 gives us a minus 25. Those terms are again unlike, so we cannot simplify that expression any further. That is our final answer. Please try example 12 on your own. Pause the video and bring that into your teacher to have it checked to make sure you have done it correctly. Moving on to examples 13 through 16. Example 13, 9 plus 7y minus 3z plus 5y minus 5z minus 3. There's a lot going on in this algebraic expression, so what I like to do is I like to color code or make boxes or squares or circles or something around like terms so I don't get confused and I know that I'm combining everything that needs to be combined together. So the first thing I'm going to look at is the 9. I'm going to find everything that is like with the 9 and combine them together. So I have the 9 and the negative 3. When I combine them together, I get 6. Next, I'm going to look at my y terms. I have a plus 7y. I also have a plus 5y. When I combine those together, I get a plus 12y. The last thing that I have in this algebraic expression is the minus 3z and the minus 5z. When I combine those together, I get a minus 8z. Example 14, 5x squared y to the 4th plus 3x to the 4th y squared. The first thing that you should automatically see is that these two terms are unlike. The variables are not the same. They do not have the same exponents. So I cannot do anything to this expression. It is already simplified. So we are done with this example. That one was very easy. It's already simplified. Example 15, 8d plus 3 times the quantity of 2d minus 3 plus 15. First thing you should notice is we have grouping symbols, and inside those grouping symbols, the terms are unlike. So to get rid of the grouping symbols, I need to distribute. So I'm going to distribute the 3 to the 2d and the 3 to the negative 3. I'm going to bring down my 8d so I don't forget about that when I'm computing my final answer. 3 times 2d gives us a positive 6d. 3 times negative 3 is minus 9. And then again, I'm going to bring down my plus 15. Now I have to look at combining my like terms. So to do that, I'm going to find all the terms that are like 8d. The only one is the plus 6d. When I combine them, I get positive 14d. Then I have a minus 9 and a plus 15. When I combine those together, I get plus 6. So that is my final simplified answer. The last example that we are going to look at together is example 16, 4xy plus 5yx. You're probably noticing that the x and the y's are simply reversed in these two terms. Well, we know that because of the commutative property of multiplication, I can rewrite 5yx to be 5xy. Now those terms look exactly alike. I can combine them, and 4 plus 5 gives me 9. The variables x, y stay the same, and 9xy is my final answer. On the next slide, you're going to see examples 17 and 18. Please pause your video, copy these down, try them on your own, and bring them in to have your teacher check them tomorrow. Thank you.